The IRC Advanced Film Division's resistors use a proprietary tantalum nitride process that results in rugged, ultra-stable resistive elements free of the reliability and corrosion problems associated with nichrome resistors. This demonstration compares the performance of IRC's TaNFilm resistors versus comparable nichrome resistors when each is exposed to moisture in the presence of an electric potential. The unencapsulated resistors used in this test were manufactured at IRC's Advanced Film Division. The test apparatus was designed by IRC application engineers to hold the resistor securely while providing an electric potential supplied by a standard 9-volt battery. First, we measure the resistance of the nichrome resistor. Prior to moisture exposure, the resistor shows a value of 20.51 kiloohms. As a drop of deionized water is placed on the nichrome resistor and a potential is applied, bubbles inside the water droplet begin forming, caused by electrolysis of the water itself. Seen in closer magnification, the resistive element can actually be seen to dissolve as the water droplet wicks up the resistor traces. In an actual application where there would likely be a smaller volume of moisture in contact with the resistive element, this process would occur over a longer period of time. The nichrome device is dried using compressed air. Part of the resistive element itself has literally dissolved away. Measuring the resistance value, we find that the resistor has experienced catastrophic failure. A reading of 1 indicates an open circuit. Now we'll repeat the procedure with the tantalum nitride resistor. Measuring the TaNFilm resistor, we see that it shows a value of 14.94 kiloohms. Note that although the two resistors used in the test are of similar size and configuration, their values are not identical due to the different sheet resistivity of the materials. Placing a similar volume droplet on the surface of the TaNFilm resistive element, similar bubbles are seen showing a presence of a potential. Unlike the nichrome device, however, the resistor material does not dissolve. The reaction is limited due to the self-passivating properties of tantalum nitride. This self-passivating property is why TaNFilm resistors are ultra-stable in humid conditions. After applying the potential for the same interval as the nichrome part, the TaNFilm device is dried using the compressed air. Although there is a small area of discoloration, the resistive element is intact. After measuring, we find that the resistor has experienced a slight positive shift, registering 14.96 kiloohms, or a difference of less than 0.14% in resistance value. Tantalum is a valve metal, one of the few elements that form an adherent oxide when placed in an electrolyte and a potential is applied. For tantalum nitride, the material used in IRC's TaNFilm thin film process, a layer of tantalum pentoxide is formed on the surface during processing, limiting the reaction. This naturally occurring property of TaNFilm yields superior performance to competitive technologies, which rely instead on applying a thin oxide of silicon or tantalum as an artificial passivating layer. IRC's tantalum nitride thin film resistors have a proven resistance to corrosion when exposed to moisture and are used where precise resistance values are required over time under the most severe environmental conditions. The ultra-stable properties of TaNFilm make it ideal for chip resistors and resistor networks that must perform in harsh environments such as automotive underhood applications, instrumentation, medical, military and aerospace, communications equipment, and portable electronic devices. IRC offers TaNFilm devices in a variety of surface mount and through-hole package types in both chip resistors and resistor networks for commercial and military programs. Contact your local IRC distributor or visit www.irctt.com for reliable resistor solutions.